Hi, welcome to this video, and in this video we're going to discuss partial fraction decomposition. And this is a skill you will use once you get into calculus. So it's completely calculus driven, and we're just teaching you this skill now so that you will have this skill as you progress into your higher level math classes. And I thought one of the best ways to kind of give you an idea of what partial fraction decomposition is to show you an example. So I've gone to a website that this is a great website for those of you heading to calculus in the future, where he takes you through a lot of topics. So I highly recommend it. And if you'll just look at this example here, this is a problem that you would run into maybe Calculus 1 or maybe Calculus 2, and you need to integrate this expression. So as it's written here, it's kind of a difficult situation to deal with, but if you can take this expression and you can break it into these two fractions here, as you can see, then you can split the problem up and you can do these separate steps in your integral. So basically what I thought would be interesting is to just kind of show you how they got from this 3x plus 11 over x squared minus x minus 6 to these two terms here where you have the 4 over x minus 3 minus the 1 over x plus 2. So let's go through that. So I've copied that problem over here. And the reason we're doing partial fraction decomposition now is because it directly ties into systems of equations, and that is what we have just learned. Remember, the first thing you're trying to do is figure out how they got these two expressions. So remember, we don't know these expressions yet. That's what we're trying to figure out. So what you do is you factor the denominator. Sometimes it's already in factored form, but this one we need to factor. Okay, and you want to set up a fraction with each of these factors. Okay, and then what we're trying to do is figure out the number on the top, the numerator of each of these fractions. We already know the answer, right? We already kind of know what we're going to get, but pretend like you don't know that yet so we can find it. And you just put some kind of variable on the top here, and I'm going to use a capital A and a capital B, but if you Google this or watch other videos, you'll see that you don't always have to use an A and a B. You can use different things. And then you want to treat this like a rational equation, which is something else we've already studied this semester. And you want to multiply through by your least common denominator. So your least common denominator is the x minus 3, x plus 2. So you're going to be multiplying through this entire equation. All right, so I'm going to write that across the top here. And then, as you've already studied, you can do some reducing and simplifying. All right, and then let's see, in this term here, the x minus 3's will simplify out, and you'll have a times x plus 2, and then you'll have the x plus 2 simplify out, and you'll have b times x minus 3. So now what we're dealing with is a situation where we want to simplify the right side. And you can distribute the A and distribute the B. And then we're going to set up a system of equations. So this is a little different. This is something you may not have ever done before. That's why we're exposing you to this now, so you're ready for it later in calculus. And we're going to look at like terms. So on the left side we have a 3x, And on the right side we have an AX and a BX, and since all of those have an X, we are going to consider those like terms. And then we can just drop the X out and we can set up this equation. 3 equals A plus B. All right, and then I'm going to switch colors here, and this is a constant, doesn't have an X in it, and that matches your 2A and your minus 3B. And I'm going to set up another equation using those. Okay, and then what you have now is a 2 by 2 system of equations. So you want to solve the system of equations using either elimination or substitution. And let's go ahead and multiply the first equation by 3, and that will make our B variables cancel. So I'm going to have 9 equals 3A plus 3B, and then a second equation stays the same. We're going to stack these up, cancel. You get 20 equals 5A and A equals 4. And then we need to find our B. So I'm going to go back into that first equation and use back substitution. Put in the 4 for the A and solve for the B, which you get -1. And then you go back to your original setup up here, where we set up those fractions with the A and the B, and you put your numbers back in there. So I know the A is 4, and I know that the B is -1. All right, and then we can just clean that up a little bit with the subtraction. And there is your partial fraction decomposition. And remember, we already knew that was going to be the answer, right? Because we already looked at that on the website. But I showed you how to actually get that breakdown. Okay, so it's actually kind of fun once you get the hang of it. Okay, so let's talk about another example here. I actually got this one out of your lab manual. So if you want to find that, so you can write your steps in there, that would be good. And we're trying to find the partial fraction decomposition of this expression. So just like we did in the last one, you want to factor the denominator, and then you're going to set up a fraction for each of those denominators and use A and B. And by the way, it doesn't matter which order you set these up. If you set the x minus 2 up here and the x plus 2 there, it's fine. All of the numbers will still work out. And then you're going to multiply through by your LCD, okay, which is going to be the x plus 2 times x minus 2. And that's going to cancel out your denominators on this left side, and you'll just have a 1. And on the right side here, your x plus 2's will cancel, and you'll have an A times x minus 2. And then on this last term here, your x minus 2's will cancel, and you'll still have B times x plus 2. And then you have AX minus 2A plus BX plus 2B. And then we're going to set up our system of equations using our like terms again. So I picked this problem out specifically because a couple of weird things happen. So you notice on the right side here you have an AX and a BX, but you don't have an X term on the left. So it's kind of like polynomial long division. You know, you want to think about putting in that term, but just give it a coefficient of 0. And then your first equation will be 0 equals A plus B. And then your second equation will be these terms that are left here. So that'll be 1 equals -2A plus 2B. And then you want to solve. This is a 2 by 2 system of equations, just like we had last time. And so I'm going to multiply the first equation by 2 so that the A's will cancel. So I'm going to get 0 equals 2A plus 2B. Second equation is staying the same. Stack those up, add down your columns, and you get b equals 1/4. And then we need to find our a, so I'm going to go back into the first equation and back substitute that value for b, and then solve for a. So a is going to be negative 1/4. And then just like before, we're going to go back up to this statement here. We're going to put in the a and the b. So my a is negative 1/4, and I'll put that over x plus 2. And my b is positive 1/4, and I'll put that over the x minus 2. And then we just need to simplify this down a little bit further, because you don't use, typically in fractions, we try not to leave a fraction inside of a fraction. So actually the way this one simplifies down is that 4 just drops down, and you can put it with that x plus 2. And the same thing on the second term, the 4 drops down, and you can put it with the x minus 2. And that will be your partial fraction decomposition for this problem. All right, so practice these. You'll see as you do them, they get pretty easy with practice, and ask questions when you have them. I'll see you in the next video.